Hi, everyone. My name is Xinyang Liu, and I'm a staff scientist in Children's National. I'm very happy to be here to present our work. So one critical need in current laparoscopic procedures is the visualization of subsurface structures, such as blood vessels, bile ducts, and tumor. One easy-to-use and real-time solution for this problem is the surgical ultrasound. However, in the current setting, the surgeons has to do a mental combination of the two imaging sources, which is not precise, and also prevent a broader use of ultrasound in laparoscopic surgeries. So we created a technology that overlays ultrasound image on live laparoscopic video to give an augmented reality view so that the surgeon can see what's underneath the organ surface. So we have tested our first generation prototype in 13 IRB-approved clinical cases so far. And on the left, you can see the original video and ultrasound data. On the right, you see the fused AR image. Our first generation prototype is based on rigid ultrasound probe, and we use optical tracking to track the two imaging devices. Optical tracking has the issue of line of sight requirement. So based on the lessons we learned, we noticed that our system need to track ultrasound probe that with a flexible imaging tip. So the way to achieve this is to use electromagnetic tracking, which doesn't have the line of sight issue. EM tracking can track the location and orientation of small sensor that is to be placed at the imaging tip of the ultrasound probe. So a trivial solution to this is simply attach the sensor externally. However, as you can imagine, this solution will face many practical challenges when you want to apply clinically. So the ideal way is to embed the sensor and the wire inside the ultrasound probe shaft. So we acquired a working Lap Ultrasound probe. We took it apart and carefully ran the sensor wire from the handle to the tip and permanently fix the sensor at the imaging tip. We then put everything back together and seal up the probe. So this is our final prototype. We call it GPS Lap Ultrasound because it enables GPS-like functionality for surgical navigation. From outside, the probe is just look like an ordinary ultrasound probe, and the four-way articulation of the imaging tip is fully functional, and you can sterilize the probe. So for preliminary evaluation, we attach a second sensor externally on the GPS Lap Ultrasound. So if the EM tracking is consistent of these two sensors, we should expect a constant offset between the readings of these two sensors. So we record EM tracking data of these two sensors and position the probe at different poses and with different angulations of the imaging tip. And this is the result we have. The standard deviation for both distance and angle variance of these two sensors are very small, which means the EM tracking is consistent. So the ultimate goal why we want to track the ultrasound probe is that we want to generate a transformation from the ultrasound image space to the 3D world space. And this can be achieved by a process called ultrasound calibration. So it is more straightforward and meaningful to evaluate the overall calibration accuracy, which incorporates EM tracking accuracy. And the metric we use is the target registration error. As you can see, we have a crosswire phantom, and we place it in the water tank. The ground truth is the 3D location of the wire intersection, and that intersection can be obtained by touching with a needle. The needle also have an EM sensor in it, so the needle tip is tracked in real time. So we place the ultrasound probe on top of the wire intersection, and we can have the the intersection point in the 2D ultrasound image plane. And we can transfer this intersection point to the 3D world space based on the calibration results. And we compare it with the ground truth point. So as you can see, the TRE for our solution is about 1 millimeter accuracy, and it's comparable to attaching the sensor externally. So finally, I'll show a AR overlay as a qualitative assessment of the GPS lap ultrasound. Here, we manipulate the two imaging devices on a phantom, and at the same time, you can see the ultrasound is overlaid on the video. We try to bend the imaging tip with different angulations, and you can see no matter how we bend the imaging tip, the overlay is generally quite good. So in summary, we successfully embed the EM sensor inside the lap ultrasound transducer, and we demonstrate the EM tracking and calibration accuracy of the GPS lap ultrasound is comparable to the case of attaching the sensor externally. In the future, we will seek partnership with a surgical ultrasound company to develop a clinical-grade GPS lap ultrasound probe. Thank you.